All right, I see. I think it would be a good time to start. So hello, everyone. I am Mark Powers. I am the DevOps lead on Chameleon. And today I'll talk a bit about storage, science, and sanity. So the topics I'll talk about today are resources, the resources on Chameleon, talking about our appliances that we support. I'll talk about snapshotting, and then I'll get to storage. And then I'll talk about some security practices and just general best practices for using Chameleon. All right, so on to resources. And I'll say, if you have any questions, feel free to drop them in the Q&A. And I can try to answer as they pop up. All right, so resources. So if you have watched the Intro to Chameleon webinar, you probably saw how to get started on Chameleon, but I'll go a little deeper. So let's say you have some idea for an experiment that you want to run. And the next question is, how do you find the resources that are required to make that experiment possible? So for example, maybe you need some GPU to run a machine learning experiment. Maybe you need lots of storage. Maybe you're working with storage hardware directly. There could be networking equipment you need, FPGAs. Maybe your experiment requires lots of memory. But the question is, how do you find that sort of stuff on Chameleon? And the solution will be to use our hardware browser. So if you go to chameleoncloud.org/hardware, and you can find this on our website. If you go to experiment and then hardware discovery, you'll be taken to our hardware browser. And this will show everything that's on the Chameleon testbed. So let's say you want to find a GPU node. We have these broken down by different types of GPUs. So for example, if I want a P100 GPU, I can click on it. I can filter by more information, but all of our GPU P100 nodes are the same, so there's not much more to filter by. And then I can click view, and it shows me more detail about all of those nodes. So for example, this will tell me a bit more. It says the GPU count. It tells me the GPU vendor. This is the most detailed view of the hardware. You can also click on the hardware name here, and it'll open up some more information, giving you, the rack, the number of threads, information about the processor. This is where you could also inspect more into the storage devices on the node. So for example, this just has one Seagate disk. You can look at the networking adapters that are on a particular node. But this is going to give you the detailed view of how that you're going to want if you're requiring specific resources. Other things you can do, if I click back, you can see what FPGA options we have on Chameleon. And here you can see they're both at TAC or UC. So one thing I can do is I can, let's say I want to run my experiment at UC, I can filter by UC. And then if I want a GPU, I can see what GPU types are available at UC as well. So I can click view and see all of these different GPUs at UC. So let's say I am looking at this one, NC35, and I determine that's the best one for my experiment. The next thing you'd want to do is check, when is this node available? So up here is our availability calendars. So if you click on the button for UC, because that's where this node is, it says here site UC also. It'll show you this page with a lot of colorful bars. So each of these rows represents one of the nodes on Chameleon, and the colorful boxes inside of it are showing when that node is reserved. So for example, a lot of the nodes are actively reserved. And then some of the nodes also, and this happens a lot with GPUs, people reserve them in advance. And that's because these are highly demanded. So if I scroll down to NC35 down here, here it is, NC35. I see that it's actively reserved. So this node, I won't be able to create a lease right now. But if I look, if I highlight over this, it says it's reserved through the 11th. And that means I could create a lease after that time if I really wanted this node. But I can look at this calendar and see, there are some other nodes, NC46 and NC57. Both of those are available right now. And so if I want to use a node, I could take a look at those. So after checking availability, I can go into leases to actually create the lease. I click that button there. I enter my lease name, which I'll call just mark lease for now. And then if you click next, I'll click reserve hosts. And now I can change the filter here to specifically get the node that I was looking at. So I would recommend to choose node name, and then you can scroll down the list of all of the nodes. So originally I was talking about NC35. We saw that it wasn't available right now, but just for the demonstration, I can choose that. And you can see some of the other properties you could filter by. But I won't actually create the lease because I don't need it right now, and I'll close that out. So that's kind of an overview of how to find hardware on Chameleon, how to find resources. So if there's any questions about this, I see there's one about the recording. Yes, we will make the recording available. So check the mailing list for that. I think we'll post it to the mailing list after the webinars. Okay. I will say that's answered live. All right. On to the next topic, appliances. So at this point, you use the resource browser to find and reserve the hardware that you need for your experiment. So the next question is, what about software? How do you get started? Maybe you need some particular operating system, and on top of the operating system, you'll likely need other things too. So I do see someone typed a node before, or a question. I'll answer that before I go on. So when a lease is terminated, will the associated nodes be deleted automatically as well? Yeah. So once you make a lease for a resource, once you make a lease for a resource, and that lease ends, then any server you launch on that node will be deleted. So if you have any data stored on that node, or if you set up your software on that node, once your lease ends, all of that is going to disappear. And so I'll get to in a little bit of what you can do so that all of your important stuff isn't lost forever. All right. So the first part, though, of getting your software running is finding an appliance. And an appliance on Chameleon is a pre-built operating system image that typically we're the ones who supply them, but our users also can create appliances. So if you go to our appliance browser, which you can get under experiment and appliances, you can see a list of the operating system images that we have pre-built, and as well as our users. But I'll filter by Chameleon supported for now. So here you can find a list of various things. For example, here we have Ubuntu images, 16, 18, and 20. These are kind of, the base images, pretty standard, just the base operating system. But one thing you may desire for your experiment is have Ubuntu with CUDA so that you can use the NVIDIA GPU easily. And so we also provide an appliance for that. And you can use that when you're launching your node to get a bit of a head start so that you don't have to configure CUDA yourself. We also have appliances for things like Jupyter Hub here. this would just come pre-installed with a Jupyter Hub server that you can use. And that would allow you to use, maybe if you have a GPU node, you could use that GPU inside a Jupyter notebook. So I'll go back. One more thing I want to show off here is we also have some complex appliances. So if you go to launch a normal appliance, it'll just be one node, for example, one Ubuntu node. But there are some cases where you want multiple nodes at once. So this is a network file system, and that has one server node, and that node is storing some data, and then you can have clients that connect to that server. So this is called a complex appliance since there's multiple nodes involved. And you can use this to help you set up something like a network file system easily. So that is kind of an overview of the appliance browser. Again, if anyone has any questions, I'll peek at the next topic though. And we kind of talked about it a second ago. So you can run an image. Let's say you run a CUDA image and you're doing some data science in Python. And along with that, you're going to have to set up some other software, maybe PyTorch or some Python library, and you configure it and you get everything just right. As I just mentioned, your lease is going to end eventually. Even though you can renew your lease, somebody might reserve the node after your release, and that'll prevent you from renewing infinitely. And so the question is, how do you avoid having to go through the pain of setting up all your software again? I know it can take some time. And another thing is how do you deal with, all of your data on your node might be part of it. How do you deal with that once your lease is over too? So the answer to this first question, how do you avoid setting up all your software again, is with Snapshotting. So we provide this tool, CC Snapshot, and this is on our documentation. You can run it and it will capture the state of your node and pack that all into an operating system image. And that way you can, the next time you go to launch a node, you can use that operating system image to be in the same state that you were when you made the snapshot. So this is best done when you just finish setting up all of the software that you're going to need for your experiment. So for example, if you just launched Ubuntu, you installed PyTorch and all of your other libraries. At that point, you can take the snapshot and you kind of have the minimal fresh state for your experiment. Now you could snapshot at any time, but there are some things you may encounter. So if you create too large of an image, if you create too large of a snapshot, it'll take a long time to capture, and it'll also take a much longer time once you want to use that again, once you go to launch another node with that snapshot. And for that reason, we really recommend to avoid including large files and data sets in your snapshots. So there is a way to exclude this when you're running the CC snapshot command. And that way, if you forget to make the snapshot at the beginning and you've already run your experiment and you have some data or you have some input data already configured on your node, you can exclude those files and create a smaller snapshot that'll work. That'll give you a better experience. All right. So the next question that we've been dancing around is, if it isn't best to store my data in a snapshot, how can I store it? And you'll encounter this, for your experiment, you may have a need for a lot of input files. For example, if you're running a machine learning program, maybe you have photos as input, and those can take up a lot of storage. And once your experiment is done, you might have generated a lot of output. So one problem our users may encounter is that our nodes on Chameleon don't all have terabytes and terabytes of storage. I can escape this, let me go back to that resource browser. We have storage type nodes here. And if I click view, we can see that these nodes have a lot of storage, like 200 to 400 gigabytes. This one says more than 1 terabyte. And I think I should be able to see more if I click more detail. Yeah, this node has tons of 2 terabyte drives. So this would be a great option to store your data, but not all experiments can be run just on this node alone because it doesn't have a GPU, for instance. So how do you effectively manage all of this, and how do you store all your data? So there are 3 things to talk about here. The first is the object store, which is powered by Swift. The next is an NFS, a network file system that's you can attach to bare metal nodes. And then the last thing will be Chameleon's file system. So the first of those options is the object store. And if you're not familiar with an object store, you may have used it on AWS, for example, but an object store is basically just a place where you can upload a file and download file. I'm sorry, that should say download. So it's really great if you're storing a data set or input files, or just in general, any large amount of data. So back to that machine learning example, maybe you have some data set of a bunch of images. You could make each of those images, you could upload each one to the object store. And then once you need it, you can download it. And there are a few ways to interact with the object store. The first is CC Cloud Fuse. And we have some documentation on this, but this is a program that you run it and it will mount the object store as a directory. And you can read and write files into that directory just as you would any other directory, and use that to store your data. That'll let you upload much more. That'll let you upload more files on it than the drive in your node may fit. There are some limitations of Cloud Fuse. We find it to be kind of unstable. Some of our users run into issues where it disconnects. And in particular, it's not great if you're editing a file. For example, if you have a log file that is constantly being updated, something like that, it only is able to upload and download the entire file at once. And so a use case like that, this isn't the best tool for. But another way to use the object store is via Swift. And Swift has a few clients. So we have some documentation on the Swift CLI, but you should be able to use it with Python as well. And Swift, as I mentioned, it lets you download and upload files. So this would be easy to integrate into your program. So for your machine learning program, what you could do is only once you need a input image, that's when you go, you invoke the Swift library and it'll download the input you need. Only when you need it. And then once you have some results, you can upload those back to the object store. And this should work great for that use case. The next way I've mentioned of using storage on Chameleon is setting up an NFS. So I mentioned we have this appliance that you're able to launch on Chameleon, or you could configure this via any NFS software that you can configure normally on Linux. Chameleon is bare metal, and you have the power to do pretty much anything, but you can run your own multi-node networked file system. So for example, if I reserved that GPU node earlier, I could also go and reserve this node that has all of these big drives. And I can use this node as my file server. And that would allow me to store all of that data and make use of the specialized hardware that was on the GPU node. Yeah, so this is where those storage nodes would really come in handy. So you may be saying, that sounds great. I'm not super into setting up my own NFS all the time. And we understand that. And that's why we're working on Chameleon's file system. And this is something that we're close to finishing. And it'll let you use an NFS, just like I talked about on the previous slide, but it'll be run by us. And so it should be a little easier to get started with it. And we're hoping to finish this up this month. So if you're interested in this, you should be able to make use of it soon. So be sure to follow our blog and our users mailing list, which you should be subscribed to if once you sign up for a Chameleon account. You can manage that subscription, I think, on your profile page. Okay. And I think this is it for storage. Are there any questions before I move on? Okay. I will move on. So the next thing I want to talk about is security. And firstly, why is security important on Chameleon? So I mentioned that Chameleon is a bare metal testbed. You can reconfigure pretty much anything on your node that you want to. And this means that we're more vulnerable, in the sense that we can't prevent our users from doing things that may be insecure. And if we do have a security incident, that affects a lot of things. It can affect Chameleon, it can us operators. Resolving security incidents will end up taking our time, and that takes our time away from helping out users run experiments. That may also affect our reputation. Like, it doesn't look great if Chameleon is sending a bunch of malicious traffic all over the network. The people we work with don't like that. If you have a security problem, you may also end up affecting other Chameleon users, and hurting their experiments. Your node will be located fairly close to their node probably, and your node could be abused to impact those other people. And maybe this will get your attention, but if you have a security incident, it's really going to end up affecting you a lot. So not only may it affect the experiment you're running on that node and any work you have on it, but we're going to come and have to talk to you about what happened. And we may have to terminate your experiment as it's running if we notice something is happening. And if depending on the severity of things, we may have to disable your account, and resolving these issues may take days or weeks, and that could cause you to miss a deadline. So keep in mind security when you're using Chameleon. So the next question you'll probably have is, yeah, that sounds important, but what does it actually mean to keep your node secure? And how do these things happen? So remember that there's no such thing as security by obscurity. And that means, you can't just get away with saying, oh yeah, I'll just run this thing on my node. I'm sure no one will notice that I'm running an insecure version of Apache Spark, for instance. These days, everybody is out there scanning the internet for vulnerable versions of software all the time. And you're going to be found if you do that. So one thing to keep in mind is, don't install insecure software if you can avoid it. A lot of times we end up seeing people install things like Apache Spark or Zookeeper or VNC, and certain versions of these have well-known vulnerabilities that people are all the time trying to get into. Another way that security problems happen are by configuring software poorly. So that means using a default password, for example, on an application that is internet facing, that'll let a user log in and change things. And this includes allowing any password access via SSH. That's something that is cracked all the time. And when somebody finds out that you're running, an insecure version of some software, or they crack your SSH password, they're going to infect your node with a bot miner or crypto miner, botnet, and do some damage. And that's when hopefully before that you don't let it get to that step. You should never let it get to this. But this is when we would have to take action against your experiment and shut it down. So the practices you should follow when you're running experiments on Chameleon. Firstly, you should leave default firewall rules in place. So all of those appliances that are Chameleon supported, we make sure have strict firewall rules, so they don't allow you to connect to ports from the outside on other ports other than just SSH by default. And so, if you had Apache Spark and installed it, this firewall would prevent it from being visible to the outside traffic, which will prevent it from being abused. But it may be the case that you really want to use something publicly. So there are a few things you could do. One would be to hide any insecure software on a private network instead of putting it on the public network. So Chameleon allows you to create isolated networks that you can connect your nodes to. And you could use a bastion host. So you would have one node that is visible to the internet that is secure. And that lets you securely get through to these other services. And we have some information about that on our blog. If you are running insecure things, you should really limit the amount of time that they're running at all. And so make sure to not leave vulnerable things up any longer than you have to. But one thing that is really great if you do want to run something internet facing is consider if you actually need to update the firewall in the first place. So I understand, let's say you want to use Jupyter Hub, like I talked about at the beginning, and you want to use that on a node that has a GPU so that you can make full use of it. That would require you to open port 8000 on the firewall so that you can connect to it. But another way to connect to port 8000 is to use an SSH tunnel. And this will keep everything secure as it is going through SSH. So if you run this command and input your IP, that'll make it so port 8000 on the remote machine is connected to port 8000 on your local machine. And then locally on my laptop, I could go to localhost :8000 in my browser, and it would redirect all that traffic securely over SSH to my node. And that will make it so, I don't have to adjust the configuration. I don't have to make anything insecure at all on my node. So other things to consider, I mentioned SSH is secure, but that's really only the case if you're using key-based SSH authentication. I mentioned on the previous slide, don't update it so that you can use a password. That's a bad idea. But also with those SSH keys, it's important that you don't share, copy, or upload a private SSH key. You should generate it on one machine on your laptop and leave it there. And you're only going to ever upload the public SSH key to your node so that you can SSH securely to it. And if you have more questions about this, we have a blog, and we'll make sure you have access to these slides. But we have a blog post about security practices on Chameleon with a bit of more information. So again, feel free to ask any questions about security in the chat, and I'll try to get to them. But the next topic I wanted to talk about is kind of just our blog in general. I've been mentioning it a few times, and we are trying to use the blog to communicate how to use Chameleon effectively with our users. So there are a couple things we post about. One of the topics is user experiments. So for example, we recently posted this article about one fish, two fish. And this was an experiment about using Chiat Edge and Chameleon to survey fish in a bay in Florida. Another thing we post on our blog is monthly change logs. So you may see those in your email, but that just is us communicating what we do on Chameleon every month. We also post tips and tricks blogs monthly, and that is where you can find a lot of the things I've been talking about. The security practices, for example. This month we posted about using Trovy, which is our reproducibility platform. And we'll have a webinar about that as well later this week. So if there's a topic on Chameleon that you're interested in, but you can't seem to find more information about, just ask us, and we'd love to share more information and potentially create more resources on our blog to explain that. And the last topic I have for today is some of the best practices on Chameleon. So one thing is Chameleon is a shared platform, as you may have noticed. That's why we have to use reservations so that people can effectively share resources. And part of that is to create your lease in a way that it isn't hogging all of our resources. But then also, once you're done with your experiment, you can delete that lease early. But there are also other resources such as IPs and networks that you can delete to free up resources on Chameleon too, if you don't need them. Other things that you may be interested in is a lot of our nodes in the resource browser. Here, let me pull that up real quick. I'll have to go back. And it'll load for a second. But that's no problem. Okay. If I look at number of threads, most of our nodes have 48 or more. And for a lot of use cases, you may not need that many, not powerful of a computer, of a node. And so maybe you can set up VMs to effectively make use of our resources for your experiment. We also have a VM platform, KVM, that you can use instead of bare metal. And another way to use Chameleon effectively is to contact the help desk as you have questions. So you can find that on our website. Let me just show you the buttons. But from any page on ChameleonCloud.org, there should be this help desk button. And you can just click create new ticket. And that'll let you contact us, and we'll see that hopefully within a day and be able to help you out. So I think that is all I have prepared, but I see we have a question. So can you extend your lease after 7 days within the 24 hours? So yeah, the way we use reservations, your lease is limited to 7 days at a time. So the first time you make a lease, you'll only be able to make a 7-day one. And then once you go to renew it, you can add 7 more days. And each time you go to renew it, you can add 7 more days. And that's one option for sure. If now, let me see, do I have the calendar open still? I don't, but I'll open it real quick. And let me show off the GPU nodes, because this is where it becomes a bit of a problem. So if you can keep renewing your lease up to a point, but as we see, there are some other people who have experiments starting in the future. And so if the person who has this node, P3 GPU 10, if they try to renew their lease, it'll tell them, I can't. And that's because it'll bump into this other person's reservation. And that's just how resource sharing has to work. But have no fear, because this is why we let you we have storage solutions, and that's why we also have CC snapshot, which would allow you to create that snapshot and launch that on a new reservation from the same place you were on your previous server. And yeah, at this point, I mentioned that's the end of my slide deck. And so any more questions I'm open to answer. Or I don't know if any other, if anyone has any comments. Okay. Well, I think I will stick around for a little bit in case anyone is typing up questions. But thank you all for attending, and good luck with all of your experiments on Chameleon. And don't forget, we're always there to help out. Just feel free to contact us. Yeah, thank you all for attending.